So what are we doing today? We're going to use the limit definition of the derivative to calculate the slope of a function at a point. How are we going to do this? We were going to take the limit as h goes to 0 of the difference quotient to find the derivative and then find the slope at a point. We're going to use this a lot. Eventually, we're going to learn some shortcuts, but for the time being, it's important that we understand where this all is coming from. This is something that we've done before. The limit as h goes to 0 of our difference quotient, this is what we did before, right? So when we have this represents the slope of the function based on what the x value is. Because the thing of it is, the only time when slope stays the same is if we've got like a straight line, right? Once we start getting into curves like parabolas and cubic functions and quartic and quintic functions, and even getting into the more complicated shapes like exponential functions, natural logs, uh, rational functions, all of them, there's a value for the slope. And we're going to be able to figure out what that is by running it through the derivative. There's many different ways that a textbook might imply that what you're doing is the derivative. So if they do like this uh, little apostrophe up here, that's called a prime. If they call something f prime of x, that is the derivative. Or they might call it y prime, like y equals instead of f of x. Another very common way, you'll see like this. And this variable up top may be different. Maybe they'll do dy dx. I've seen this before. I've seen this is the derivative operator. I've seen this before. But I'll tell you, the three most common ones that you will see are these. This one, and this one. Not often with this one, and even less often. I'm just because I've seen these before sometimes, but it's usually these three you're going to see, and that's going to mean, hey, this is the derivative. All right? So when we are working on this, so let's look at these couple problems. We've got the slope that we're trying to find at these points. And so the easiest way to do a problem like this is to sort of go out a little bit from it and see if you can estimate sort of where it is. If you look, it looks like it's sort of up 1 over 1, maybe a little more, a little bit less, but this seems to be about 1. And I'll tell you in advance, there's going to be like a little drop down menu. It's going to be like, is it 1? Is it -1? Is it 2? Is it 17? So the one answer that's even remotely like good will be pretty clear. And then for like this one, kind of 3-ish, I think it looks like. Right, like up 1 over 3 here. And again, what we're doing here is we're taking the slope of a tiny little line, 2 points on this line, and approximating, right? Our goal eventually is to get these 2 points closer and closer to each other. Like, same thing here. You can't really just do this by eye necessarily, but here what they give you is they give you the tangent line, and they want you to figure out kind of about where that slope is. And it looks like you're going up one, if you're going over and up, it's about 2. So a lot of these, and again, you're going to get like a little drop down menu or just they're looking for which whole number is this kind of sort of close to. It's not going to be exact. You're not going to be asked on a picture like this to figure out exactly what it is, because it's not going to be perfect. Or if it is, there's going to be like specific lattice points that you can look at. Like, see how none of these go through crosshairs like this. They're all off by a little bit. Even this one is close, but no cigar. So the thing of it is, this tangent line, you're not going to be able to get an exact answer, and you're not meant to. And that's just sort of what I want to confirm to you right now, because they're gonna be, it's gonna feel like kind of weird, but ones like this, they're going to specifically tell you, just estimate this. It's okay. Just give me about. Okay. So now find the equation for the line tangent to 1 minus 4x squared at this point right here. So here's the thing. Remember a couple weeks ago we were talking about they're going to give you the exact same information in 15 billion different ways. Here's another way. Find an equation. So that's the same thing that we did last time. For the line tangent to, so that's what we're talking about. For the line tangent to, they want the slope. So take the derivative at, well, here's my x1 and here's my y1. Ta-da. So the hardest part about this is just going to be taking the limit of the difference quotient, taking the derivative this way. But remember, it's the top is designed to cancel out, so it's not going to be that bad. Let's do it like we're doing f of x plus h. So we got 1 minus 4, and then wherever you see an x, you're going to place it with x plus h minus, square should be up here, sorry. So there should be, I'm just going to redraw this because I don't know. There we go. Over h. So now you're going to FOIL this, and a lot of stuff's going to cancel out. You can already see that there's stuff that's going to cancel out. You can do that right now. You can be like, okay, well, that 1 is going to go away with that 1, right? So you can even make it simpler before you do your minus, so plus, then you can distribute this 4, right? All over h. Limit as h goes to 0. And we're going to distribute that thing in here. So now we've got negative 4x squared minus 8xh minus 4h squared plus 4x squared, right? That's going to cancel out again. These go away. All over h. And look at what we're left with. We've got negative 8xh minus 4h squared. There's an h in each of these, so we're going to get to cancel some more stuff out. H cancels. One of the h's cancel. This h cancels. And so now look at what we're left with. The limit as h goes to 0 of negative 8x minus 4h. And now, if we plug in h as 0, we don't have a problem anymore, right? Look, here's our slope function. That's it, right? This is our derivative, negative 8x. This represents the slope regardless of where x is at any given time. So now what we can do is we can find the slope, our x1, our y1, plug them in. Well, let's find our slope. And where's our x at? It's at negative 4, right? So we're doing it at negative 4. That means that it's negative 8 times x, negative 4. What's negative 8 times negative 4? 32. Well, there's my slope. Ta-da! There's my x1. There's my y1. And now I'm just going to plug those things in, and I'm going to wash my hands of the whole problem. Because you don't have to do anymore. Y minus y1 equals m times x minus x1. Ta-da! Problem complete. So, to review, step 1, find your derivative, because that represents your slope anywhere. So take the limit of the difference quotient as h goes to 0, get everything sort of simplified and do your algebra, cancel. You should expect, once you get to this step here, all the things that don't have an h should go away. If there's still some random x term in there, something you did is wrong. You should have everything with an h so that all the h things cancel out somehow, leaving you with the ability to plug in h is 0 so that you can get your final answer here for the derivative. Once you have found the derivative, now we can do the exact same thing that we've been doing all this time. What's the slope? Oh, I found it. What's my x1? What's my y1? Well, let's find the slope at the place where they want it, negative 4, right? So we find the slope at negative 4, throw negative 4 in where x goes, and get your slope of 32, right? Negative 8 times negative 4 is 32. x1 is negative 4. That's what they told us. y1 is negative 63. That's what they told us here. So now all we have to do is plug those things in, and there is our equation. Some of you are going to be tempted to go further. Why? Stop there. That's the answer. Unless they specifically tell you, hey, put it in slope-intercept form, or put it in, they're not going to. But you don't need to go any further than this. You are officially done now, right? Again, find the point at which this has a horizontal tangent line. Okay, so pretty much the exact same problem. find the point. So now we're looking for our x1, y1. So we want, our goal is to find x1, comma, y1, whatever that is. And what's going to be the thing that is going to make this? Well, here's the graph, and we want a horizontal tangent line. What does that even mean? Horizontal tangent line. That looks like this, right? Horizontal. When you see horizontal tangent, that tells us that the slope is 0. That is what this means. So you can automatically, whenever you see the phrase horizontal tangent or horizontal tangent line or horizontal, whenever you hear the word horizontal, think to yourself, slope equals 0. So what we're going to do is we're going to find out where the slope is 0. So this is the graph, but we don't want the graph. We want the graph of the slope. We want the y prime. So what this means, we're going to find the point where y prime is 0. That's what we want to find. So let's do that. Well, we've got to do the difference quotient. And this one's going to be mildly painful, but we're going to get through it together. So we've got limit as h goes to 0 of anywhere you see an x, you got to put an x plus h the first time around. Minus this original one. And a lot of this stuff is going to cancel, which is what we expected. That's what we want. So let's do it out. We got to FOIL this one out. We're going to get 8x squared plus 16xh plus 8h squared. And again, see, this is an x squared term. We expect that to cancel out. Plus, and then we got to distribute this. 6x plus 6h. And again, this x term, we expect it will cancel out. Minus 8. And then again, this does not have an h term. We expect it will cancel out. What's the other half of this? Minus 8x squared minus 6x plus 8. Notice what I did is I just distributed the negative sign into all three of these over h. So now, once again, I saw this 8x squared. There better be a negative 8x squared up here, otherwise I didn't do it right. There it is. Cross it out. I found that there was a 6x here, a plus 6x, so there better be a minus 6x. There they are. Cross them out. There's a minus 8, so this had better be a plus 8, so we can cross them out. And look, all that's left are these terms here. We've got limit as h goes to 0. Don't forget about that. Limit as h goes to 0 of this now significantly smaller fraction, 16xh plus 8h squared plus 6h over h. And now we're going to cancel out all the h's from top to bottom that can come out. One from each of the top and then the bottom. Hey, look at that. Much easier now. Limit as h goes to 0 of 16x plus 8h plus 6. And then we're just going to plug in 0 for h. And look what happens. This term goes away too, right? 8 times 0 is 0. So now look, our answer for the for the slope part here, 16x plus 6. This is our dy dx. So we're going to figure out where that has a horizontal tangent line. So we're going to set that equal to 0, right? Horizontal tangent line, set that equal to 0. So we're going to do that right now. We're going to do 16x plus 6 equals 0. Just solve for x, subtract the 6, divide the 16. Negative 6 over 16, which simplifies to negative 3 over 8, right? So that's our x value. And now we need our y value. So now we're going to go back to the original one, plug it in, and then get our answer. So all we're going to do now is just plug it in and get our answer. And you could totally, if it's a calculator section, just throw that into the calculator. Actually, here's the really fun part is that on the AP exam, you could just plug the negative 3/8 in for where x is, and then just leave that. You don't even have to crunch the numbers. They'll hate you, but they can't mark you wrong. And that's all that matters, right? So let's just for giggles put it through and actually crunch all the numbers. So if you go through and you do this, square the top and the bottom here. So you got 8 times 9 over 64 plus, well, minus 6 times 3 over 8, right? It was a negative 3 over 8, but I'm just going to put the negative sign out here for simpleness. And then cross out all your common factors from top to bottom so you don't have to think as hard. There's an 8 up top, there's an 8 down below. There's a 2 up top. There's a 2 down below. So look at what we have. We've got 9 over 8 minus 9 over 4 minus 8. I'm going to put y equals here just for clarity. And then when you do this, 9 over 8 and 9 over 4 can be just like 18 over 8 here. So this is negative, these subtract negative 9/8, then minus 8, negative 9 and 1/8 when you do the math here. Or if you would prefer it as a mixed number, negative 73/8. Yeah. But either way, the goal was to find the x1, y1. Well, here's your x1, right? Here's your y1. So your answer here is, your final answer, negative 3 over 8, comma, this point right here is your point that they wanted. All right? So again, let's talk through what we just did. First, we looked at what the word said and we realized what we needed to do. We said, okay, they want the point. They want x1, y1. Where? Well, they gave us, I'm pointing, I don't know why I'm pointing. They give us the graph here. This is the equation of the line we're working with. And they told us we want to know where on this place has a horizontal tangent line, which means where on this place does the slope equal 0, right? Which tangent line, if you were to draw it, looks like this. And that's what we need to find. So we went through, we found our derivative, canceled out all the like terms. We found our derivative right here, just like this. And then we said, all right, where does that equal 0? Let's find the x value. We found the x value, and then we plugged in the x value to figure out the y value. And then we got our answer right here. And that's all there is to it. My recommendation is to give it as an ordered pair, but be mindful of what you're hearing from the robot on Math Excel. If it wants an ordered pair, give it. If it's asking you about your x and y separately, make sure to notice what it's telling you to do. All right. Last one. Here they're giving you different information while still basically saying the same thing. They're saying at t seconds after liftoff, the height of a rocket is this. They want to know how fast is the rocket climbing 10 seconds after the liftoff. Here's another key phrase that just means slope. They want you to find the derivative of this function they gave you at t equals 10, right? So like literally all we're going to do is we're going to say, well, let's find the derivative. Let's plug in 10 and then we'll have the speed. Here they're giving us distance. This is distance, right? So one thing to be acutely aware of as we go forward, the derivative of distance is velocity. This is something, if you ever are taking a physics class, that they will just expect you to know. The derivative of distance is the speed or the velocity, right? Here we're talking velocity because we could be talking about negative numbers, maybe going backwards, but in general, the two sort of mean the same thing. So we're going to find the derivative. Let's find the limit of the difference quotient here. Limit as h goes to 0 of t plus a. And you can use whatever variable you want. Like they're using t here, and that's like a lot. But like if you would rather use x, no one is going to be mad at you. So once again, we're going to distribute all this out, and then that should cancel with the 4t squared. So let's do that. So we got 4t squared minus 8th plus 4h squared minus 4t squared all over h. And again, look, the 4t and the negative 4t, we want them to cancel out. They're supposed to cancel out. That's what they're meant to do. That's the purpose of doing this. And now the h's, those two should cancel out. The h here, the h here, and the h here, leaving us with the limit as h goes to 0 of negative 8t plus 4h. Well, then if h is 0, this goes away, right? So we're left with our f prime of x equals negative 8t. And what we want to know, the speed at 10 seconds. So what are we gonna say here? How would we say that? F prime of 10 is what? Well, let's do it. T is 10. Well, what's negative 8 times 10? That's negative 80. And then always make sure to include your units. I've seen them mark off on the AP exam for not putting the units down before. So when you're writing something out, make sure to include the units.